Hey, this is Mr. Allred, and I'm going to talk to you about absolute value and more specifically solving absolute value equations. But first of all, I want to start off with the definition of the absolute value. So you should be familiar with absolute value as a statement with these bars around it. So on the left hand side, this is the absolute value of A. Now, you probably have your own definition of absolute value and how to deal with it with numbers, but we're going to be dealing with it algebraically, which means we're going to have variables in there and expressions. So you know there's two different things you have to look at when you solve an absolute, or when you evaluate absolute value. That would be that if what's inside the absolute value is positive, then it just stays what it is. Okay. If it's negative, then you make it positive. But if A is negative, the way you make that positive is to change the sign. So we have to look at, if we have an expression, both of these possibilities. Okay. So to kind of get you thinking down here, if we had the equation absolute value of A equals 5, you could look at that and definitely say, since it's so simple, that A could be 5. Okay, because A is already positive. That would fit the first line of the definition up here. But also, A could be negative 5 because you would just drop the negative and you would get 5 in the end. So two different things could be A, and when you take the absolute value of it, you could get 5. So we have to look at that as we have possibility for multiple solutions. Maybe not infinite solutions like some equations, but multiple. Okay. So let's talk about solving these equations right now with one absolute value. Okay, to keep it kind of consistent and go off some of the rules that we already have, I'm going to say that if you have an equation with an absolute value that you're trying to solve, isolate the absolute value. That means if you have the absolute value of something, get that absolute value by itself. Excuse me. So you can treat it like it's a variable and use all the techniques we have used to get variables by itself. Okay. Now once you have the absolute value by itself, you're going to look at those two conditions, and you're going to separate it into two different equations. Equation 1 comes from just dropping the absolute value bars. That's where you assume that what's in there is positive. Okay. The second equation, two completely separate equations, will come from dropping the bars and changing the sign of every term on one side of the equation. So we can assume this is the side that had the absolute value. So this is where we might assume that what was in there was negative, and to get rid of the bars, we would change it to positive or change the sign of it, which is what we'd do there. So at that point, we have two completely separate equations. And what that means is we're going to solve both of them. Okay, and that's where we could get two answers. But because in the process we may not be paying attention, or something just might not work out for the equation, I highly recommend that you check the solutions. Okay. So let's go to some examples. Okay. Here I have the equation. It's the absolute value of 3x plus 4. Then I subtract 2, and that's equal to 20 plus 2x. So the first thing we said we would do was isolate the absolute value. So in that case, the absolute value is this whole thing over here, absolute value of 3x plus 4. So I want to get it by itself. So I'm thinking if that was my variable and I wanted to get that variable by itself, I would add 2 to both sides to get this negative 2 away. So I'm going to add 2 to both sides, which means I'll add it to the 20 on the right hand side. And now There may be other steps I'd have to do sometimes, but I have the absolute value of 3x plus 4, and the 2's cancel out, equals 22 plus 2x. Okay, so my absolute value is by itself. Now I'm going to create two equations. Okay, and one of those will come from, okay, let's call it case 1, just dropping those bars. So in dropping those bars, I'll just have 3x plus 4 equals 22 plus 2x, and we're going to solve that in a minute. But before I forget, I'm going to go ahead and write down case 2, because this is so different than any other type of equation you solve that it's easy to forget. Okay, so I'm going to write this down, but I'm going to change every sign on the left hand side. Now that means it was positive 3x, so now it's negative 3x. It was positive 4, it's negative 4. So I've changed the sign of that quantity on the left hand side. Now I don't do both sides, so it's negative 3x minus 4 equals 22 plus 2x. And I'm going to solve these two separate of each other. Okay. Lucky for me, there's no fractions, there's no parentheses, and there's no like terms, so I'm going to start off by adding, subtracting on each side. So I don't have room to write all my steps, but I like my variable to be positive if possible. So in case 1, I'm going to subtract 2x from both sides, and I'm going to subtract 4 from both sides. So after the things cancel out and I tally them up, I get x equals 18. Now we will go back there and check it in a second, but let's handle the other one as well. So in case 2, I had negative 3x minus 4 equals 22 plus 2x. It doesn't matter which way I take these things. I just got to get my x's on one side, non-x's on the other. I like my x's to be positive if possible, so I'm going to add 3x to both sides. So I'm moving my x's to the right, so I need to move my numbers to the left, and I'll do that by subtracting 22. So let's see what happens after everything cancels out. I get negative 26 equals 5x, which is probably not the most expected answer. We'll divide by 5. And the 5's will cancel out, so I get x equals negative 26 over 5. So right now I've got two possible solutions. I'm going to go back to my very original equation, and I'm going to try both of these in there. Okay, so I'm going to come off to the side here, and I'm going to write down my original equation. And I may save a few steps, but 3x plus 4, that's the absolute value, minus 2 equals 20 plus 2x. So I'm going to plug in the 18, and if I plug in the 18, let's just say let x equal 18, I'm going to pull out my calculator. So I'm plugging in this 18 for wherever, x is, so I got two x's here. So I'm going to try and save myself a little bit of time. But 18 times 3, and then plus 4. So on the left hand side I get the absolute value of 58, which is positive, and that'd be minus 2, equals on the right hand side 20 plus, and then 18 times 2 is 36. So what do I get? I get 56 equals 56. So the 18 works. Okay. Now let's do the same thing with the negative 26 fifths. So we're going to use the same equation, but we're going to do it with let x equal negative 26 fifths. So this may not go as well because of the fractions, but let me see here. I'm going to do a little magic, and you can do a little magic with fractions as well. So let me pause it to save a little bit of time, and then you can do it behind the scenes. So when I plug this in, negative 26 fifths, I get the, let's go to the right color, the absolute value of negative 58 over 5 minus 2 equals 20. And then when I multiply this, I'll have negative 52 over 5. Of course, the negative 58 over 5 will turn to a positive, so it'll be 58 over 5 minus 2, which I will change to 10 fifths. And I'm trying to make everything work out here. So on the other side, 20 would be 100 fifths, though it's always hard to check yourself if you're dealing with fractions, but that would be minus 52 fifths. So if you have any questions about that, just let me know. But 58 minus 10 is 48, and that'll be over 5. 100 minus 52 is 48 over 5, so it did balance. So there we have living proof that negative 26 fifths did work out. So we got two answers that actually proved themselves worthy. The problem here is, and the reason you should really check your answers is, when you start changing the sign of some of these things, depending on how complicated they are, even though we're doing simple equations, if you're not paying attention or something a little bit out of the ordinary happens, you could pick up an answer that doesn't work. You've done everything correctly, but you ran into a situation that kind of worked against you. Okay, I'm going to do another example, but I'm going to save it for a second video.